Have you ever wondered what powers your smartphone or laptop? At the heart of every device are computer chips, the tiny brains of our digital world. For decades, we made these chips smaller and faster, but now that progress is slowing down. We're on the brink of a new era, quantum computing, a technology that sounds like science fiction, but is very real. Quantum chips aren't just better versions of today's chips. They work on the bizarre rules of quantum mechanics. Imagine a computer that can explore millions of possibilities at once, not just one after another. That's the promise of quantum power solving problems that today's supercomputers can't even touch. Think of this as the early days of classical computers, giant machines, few users, and unimaginable potential. Today's quantum computers are big, complex, and experimental, but researchers worldwide are racing to unlock their power. This technology could spark new industries, scientific breakthroughs, and ways of understanding our universe. The quantum revolution isn't just for scientists. It will impact all of us, our security, health, and innovation. So, what are quantum chips, and why do they matter? You don't need to be a physicist to grasp the basics. The next leap for humanity is happening at the tiniest scales, inside quantum chips. And you have a front row seat to this revolution. Let's dive in and see how quantum computing will shape our future. Welcome to the quantum age. For over 50 years, Moore's law predicted that computer chips would double in power every 2 years. This relentless shrinking of transistors fueled the digital revolution. But now, we're hitting a wall. Transistors are so small that quantum effects start to interfere. Electrons can leak through barriers, making chips unreliable. We can't shrink them much further, so Moore's law is slowing down. Our current computers struggle with today's complex problems, like drug discovery, climate modeling, and financial security. Supercomputers get bogged down, checking possibilities one by one. We need a new approach, not just a better version of the old one. That's why scientists are turning to quantum computing. Instead of fighting quantum effects, they're harnessing them for unprecedented power. The end of Moore's law isn't a failure, it's a call to innovate. Quantum computers use the weirdness of physics as their greatest strength. This is the dawn of a new era in computing. The universe of possibilities is about to expand. So, how do quantum chips work? Let's start with the basics. Classical computers use bits, ones and zeros, like tiny switches. Quantum computers use qubits, which can be 0, 1, or both at the same time, a phenomenon called superposition. Picture a spinning coin. While it spins, it's both heads and tails. Only when it lands do you see one result. Qubits can exist in multiple states at once, giving quantum computers their unique power. There's also entanglement. When two qubits are linked, changing one instantly affects the other, no matter the distance. This spooky action lets quantum computers solve problems by exploring many solutions simultaneously. Quantum advantage is when a quantum computer solves a problem no classical computer can handle in a reasonable time. Problems that would take billions of years for a classical computer could take minutes for a quantum one. It's not just about speed, it's about solving problems we never could before. Quantum computing is a leap from simple math to solving the unsolvable. This is the heart of the quantum revolution. The future of computing is here, and it's weird, wonderful, and powerful. Let's see what it can do. Quantum computing's potential has sparked a global race for leadership. The US launched the National Quantum Initiative Act, investing billions in research, universities, and private companies. This isn't just about faster computers, it's about national security and economic power. Quantum computers could break today's encryption, so new quantum-resistant security is a must. Quantum sensors could revolutionize navigation and defense. The country that leads in quantum will shape the industries of tomorrow: energy, medicine, finance. Government funding is fueling breakthroughs and attracting private investment from tech giants. This public-private partnership is essential to tackle the immense challenges ahead. Quantum computing is now a top strategic priority for the US. The race is on, and the stakes couldn't be higher. What will we actually do with quantum computers? They won't replace your laptop, but they'll tackle problems classical computers can't touch. In medicine, quantum computers could simulate molecules to design new drugs for diseases like Alzheimer's or cancer, faster and more accurately. In finance, they could model markets and optimize investments, making systems more stable and efficient. For logistics, quantum power could find the best delivery routes worldwide, saving time and resources. In materials science, they could help invent new materials, like super-efficient solar cells or better batteries. Even weather forecasting could be transformed, with more accurate predictions for extreme events. Quantum computing is a tool for solving humanity's biggest challenges. It's not just theory, it's a practical force for change. The breakthroughs ahead could reshape our world. The quantum future is about solving the impossible, and it's closer than you think. Building a quantum computer is a massive engineering challenge. Qubits are fragile. Tiny disturbances can ruin their quantum state, causing errors. Scientists are developing quantum error correction, using multiple qubits to protect information. But correcting quantum errors is far harder than in classical computers. Quantum chips also need to be kept ultra-cold, colder than deep space, using complex refrigerators. These systems are expensive and difficult to build. Integration is another hurdle. Quantum computers must work alongside classical ones, sharing data seamlessly. Overcoming these challenges, error correction, cooling, and integration, is key to making quantum computers practical. The path is tough, but progress is accelerating. The world's brightest minds are on the case. Quantum computing is creating an entirely new industry and a demand for a skilled workforce. It's not just physicists. We'll need engineers, software developers, technicians, and more. Universities are launching new programs in quantum science and engineering. Community colleges are training technicians to build and maintain quantum machines. There's also a need for quantum-aware professionals in fields like finance, medicine, and logistics. Entering the quantum field now is like joining the computer revolution in the 1960s. The demand for talent is huge and growing fast. Building the quantum workforce is as vital as building the technology itself. The future belongs to those ready to learn and lead. With great power comes great responsibility. Quantum computing raises big ethical questions. The same tech that could cure diseases could also break encryption and threaten privacy. We must develop quantum-resistant security before quantum computers become widespread. Access is another issue. If only a few have quantum power, the global divide could widen. We need to democratize access, perhaps through cloud platforms, to share the benefits. Quantum-enhanced AI and surveillance raise concerns about privacy and fairness. Clear ethical guidelines and global cooperation are essential. The goal guide quantum progress for the good of all. The choices we make now will shape the future. We've explored the limits of today's tech and the promise of quantum computing. This isn't just a story for scientists. It's about our shared future. Understanding quantum basics will open new opportunities for everyone. The quantum revolution will unfold over years, but the foundations are being laid now. So, what would you do with quantum power? Cure a disease? Reinvent energy? Solve climate change? The possibilities are endless, limited only by imagination. Stay curious, keep learning, and join the conversation. The future is built by those who understand it. The quantum age is dawning. Are you ready to be part of it? Subscribe for more practical finance lessons.